Good morning, students. Today we are going to discuss the two topics: significant figure and order of magnitude. So today first I am going to start the significant figures. Actually, when you are doing the experiment, you have seen that when you are taking the reading, as suppose I am just taking the one example, 2.575, then some students do the rounding and they are writing that the answer in 2.58. Okay, suppose the reading is 2.575, so we are doing the writing rounding and then we are writing the unit 2.58. Okay, so which value is more accurate, 2.575 or 2.58? Okay, so if you will see, it is 2.575. This number is having the 4 figure 2575, and 2.58 is having the 3 figure 2, 5 and 8. Okay, so according to the accuracy, the digit who are having the more figure, that is more accurate. That is why we are using this term significant figure. Actually, in any measuring instrument can measure accurately only up to a certain limit. Therefore, in every instrument, every measurement, the last digit of the observation is always doubtful. Understood? Suppose I am going to measure the length of any side of a cube, okay, and this reading I am taking by the vernier calipers. You know that the least count of the vernier calipers is 0.01 centimeter. So that means if I am getting the reading 2.58 centimeter, then in this reading 8 is doubtful. Understood? Clear? So in this one 8 is doubtful. So the length, why it is doubtful? Because the length can be between 2.57 and 2.59. Okay, and that's why sometimes we are writing the reading as 2.58. Okay, so in the measurement of a quantity, the digits measure accurately and the first doubtful digits are called significant figure. So suppose if we are writing 2.58 centimeters, here the 3 significant figures are there. Suppose I am writing here the 2.62, so here 1, 2, 3, 3 significant figure is there. Okay, so if your measurement is having more significant figure, then your reading is more accurate. But there are certain rules, okay, to determine the significant figure. So just one by one I am just dictating you the some rules of to determining the significant figure. The first rule is all the non-zero digits are significant. All the non-zero digits are significant. Non-zero, so see it here, I have written the one 23.68 or 2.368, all these two number, or you write a 236.8, all these digits are having 4 significant figure, 1 2 3 4, 1 2 3 4. If I am writing 236.8, then also it is having the 4 significant figure, 1 2 3 and 4. Clear? Decimal point does not affect your number of significant figure. Okay, so you put decimal here, here or here, no change in the significant figure. The second rule is all zeros between the two non-zero digits are significant. Okay, all zeros between two non-zero digits. The non-zero digits in this example is 2 and 3. So when I am going to calculate the significant figure, these zeros are also included. So 1 2 3 4 5. So I am writing here 5. Okay, all zeros to the right of a non-zero digit. Okay, so right of the non-zero digit. So I have written here the one example 86400. So 4 is the non-zero digit and right of this there are 2 zeros, that also including. So 1 2 3 4 5. So there are 5 significant figure. Clear? Now the fourth one, all zeros to the right of a non-zero digit but on the left on the decimal points are significant. That means if I am writing here 86400.00, clear? 86400.00, then this number is also having only the 5 significant figure. 1, 2, 3, 4, 5. Clear? These two zeros will not include in here. Clear? Now the next one, all zeros to the right of the decimal point are significant. All zeros to the right of the decimal points are significant. Like suppose I am writing it here 56.00. That means this is also having the 4. Clear? If I am writing 0.5600, okay, so this one is also having the 4 signal. Now see that there is a difference between this and this. Here the 0 is coming just after the non-zero digit. That's why here the 0 is counting, and here the before of this 0, okay, or you can say the left of the 0 is 0. Okay, so it is a 0 digit, so that's why this 0 is not including. So if after the decimal point if there is 0, and before the decimal point if there is a non-zero digit, then these zeros will be counted. Clear? Understood the difference between these two? Okay. Now the next point is, all initial zeros on the right of the decimal point but on the left of it non-zero digits are not significant. Yani it means if I am writing 0.0345 or I am writing 0.345, okay, this 0 will be not including in this one. That means it is having the these two numbers are having 3 significant figure, 1 2 3 1 2 3. These 0 will be not going to count in the significant figure. Clear? Now the next one, okay, it may be remember that the position of decimal point does not affect the number of significant figure. Understood? That means where the decimal, I have given the example of here for this one, sixth one. Suppose I am writing it here 2.58, then I am writing 25.8, so then I am writing 0.0258. Okay, all these are having the 3 significant figure. Okay, so it may be remember that the position of decimal point does not affect the number of significant figure. Understood this point? Okay, now I am going to start the next topic. Clear? And your next topic is order of magnitude. Okay, on order of magnitude, if we write the magnitude of a quantity in its nearest power of 10, nearest power of 10 means, suppose it is a, I am writing any number, suppose 365. So if I am writing 365, like 365, okay, and nearest power of 10, that means if I am writing it is 3.65 into 10 to the power 2, like this I am writing. Okay, so if we write the magnitude of a quantity, okay, in its nearest power of 10, then the nearest value obtained in power of 10 is called the order of magnitude of that quantity. Understood? If we write the magnitude of a quantity, suppose it is a 365, and I am writing this one in 3.65 into 10 to the power 2. Okay, so nearest value obtained in power of 10 is called the order of magnitude of that quantity. But someone says, why I am writing 3.65, why I am not writing 0.365, why I am not writing 36.5, okay, so why I am not writing 0.00365. Okay, so there is one rule behind this to find the finding the order of magnitude. Okay, and that the rule is, the magnitude of a physical quantity whose order of magnitude is to be determined, okay, you have to write in the form of n into 10 to the power x. Clear? Where n is a number between 1 and 10. N is a number between 1 and 10. Clear? And x is a positive or negative integer. Clear? x is a positive and negative. Now the two rules is coming it here. First is, if n is equal to or smaller than 3.16, okay, then the order of magnitude is 10 to the power x. Clear? But if n is greater than 3.16, n is greater than 3.16, then the order of magnitude is 10 to the power x plus 1. Clear? I am just giving you some example here. Okay, suppose I am writing the first one is 2.2 into 10 to the power 2. So this 2.2 is less than 3.26, sorry, 3.16. So that means the order of magnitude is 10 to the power 2. Clear? If I am writing this one 4.50 into 10 to the power 2, here the 4.50 is greater than 3.16, so that means the power is x plus 1. Order of magnitude is x plus 1, so that means it is 10 to the power 3. Clear? Suppose another example I am taking, it is 3.25 into 10 to the power minus 3. Then it is, this one is also 3.25 is greater than 3.16. So again order of magnitude is x 10 to the power x plus 1. That means it is 10 to the power minus 2. Understood? So basically the order of magnitude gives an idea about how big or how small a given physical quantity is. Okay, so in this video I have explained you the two topics, significant figure and the order of magnitude. Okay class, thank you.